Hey space buffs, just how well do you know our solar system? Guess the planet. It's more than twice as massive as all the other planets combined. It's covered with striking swirls and stripes, which are actually windy clouds of cold ammonia and water, floating in an atmosphere of hydrogen and helium. Still no clue? Then look at this. It's the infamous Great Red Spot, a giant storm larger than our home planet that has been raging for hundreds of years. Right you are. This cloudy world is Jupiter, and the main question is this planet our enemy or friend? NASA's Juno orbiter is exploring this gas giant at the moment, sending us tons of useful data. Jupiter is so big that 11 Earths could fit across its equator. If our planet was the size of a grape, Jupiter would be a basketball. The gas giant is the fifth planet from the Sun, orbiting around 484 million miles away. And even though for us Earthlings, our blue-green world seems to be the most important among all the other planets, we live in Jupiter's solar system. After all, it accounts for 75% of the mass of all the planets in our star system. And it's also 318 times more massive than Earth. And whatever Jupiter wants, Jupiter gets. Jupiter wants to throw stuff across the solar system? No problem. After all, this gas giant doesn't have its immense gravity for nothing. It yanks material from the asteroid belt, stopping poor space rocks from forming anything larger than Ceres, the only dwarf planet located in the inner solar system. Jupiter is hungry, it gobbles up comets, asteroids, and whatnot. Jupiter's bored. It hurdles everything it manages to capture on wayward trajectories. This gas giant must have caused a lot of destruction over the course of its life, which is around 4.5 billion years. But here's the thing. Some scientists think that we might owe our very existence and the existence of our planet to Jupiter's protective gravity. It may sound confusing, but by greedily swallowing up dangerous space objects, this planet vacuums the solar system. Other astronomers don't agree with this theory. They claim Jupiter is a hooligan, bothering peaceful and safe comets and sending them to unexpected places. You see, some of the most dangerous objects in our solar system are long-period comets. Those are huge chunks of ice and rock coming from the depths of the Oort cloud, which lies far beyond Pluto. Some of them get pushed into the inner solar system, where they dash past the Sun. There's a chance that the most devastating extinction on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes them this way and that, consuming some of them like delicious ice rock burgers. But does Jupiter push such comets out of their dangerous orbit so that they don't smash into Earth? Or does this gas giant actually divert the trajectories of the comets that would otherwise miss Earth? No one knows. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen, the material stars are mostly made of. But the planet's mass isn't enough to start a fusion reaction in its core, and that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 75 times its current mass. Paradoxically, if Jupiter even got more massive, it would also get smaller. This additional mass would make the planet denser, and it would cause the gas giant to start pulling it in on itself. Astronomers are almost sure that even if Jupiter was 4 times its current mass, it would still remain the same size. Jupiter has between 80 and 95 moons, but one of the most popular ones these days is Europa. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. That's what Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system, looks like. And the coolest thing about this faraway place, it might host life. Astronomers consider Europa to be one of the most promising places in the solar system to search for new forms of life. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it's still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. For a long time, scientists have been wondering about Jupiter's X-ray auroras. What causes them? It seems like the 40-year-old mystery has been solved. Jupiter's breathtaking X-ray auroral emissions are triggered by electrically charged particles called ions. They crash into the gas giant's atmosphere, and here's the result. But astronomers couldn't understand how those ions got to the atmosphere in the first place. But recently, they've seen the ions surfing Jupiter's magnetic field all the way down to the planet's atmosphere. Astronomers have received this data thanks to NASA's Juno spacecraft and ESA's XMM Newton telescope, situated in Earth's orbit. Now, on our home planet, auroras are only visible in a belt surrounding the magnetic poles, between 65 and 80 degrees latitude. Anything beyond 80 degrees and auroras disappear. But Jupiter's X-ray auroras are much more inconsistent. They pulsate regularly poleward of the main belt, and sometimes they're different at the north and south poles. Scientists have figured out that this pulsation is caused by the fluctuations in Jupiter's magnetic field. You see, when the planet rotates, it drags behind its magnetic field. Struck by the particles of the solar wind, it gets compressed. This heats the particles trapped in Jupiter's magnetic field, and they start moving along the magnetic field lines, producing magnificent auroras. Another feature Jupiter is famous for is its Great Red Spot, an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the surrounding cloud tops. The storm is more than twice as wide as our planet. At the edges of the storm, the wind speeds reach 270 to 420 miles per hour. That's faster than Earth's tornadoes. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet, when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once several enormous storms could have come together, creating the Great Red Spot. And now it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with the cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color, but so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s. And for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with small pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot might become circular. or it may simply disappear.
A few years ago, NASA caught a mysterious green glow on Jupiter. It was moving at breakneck speed and almost escaped detection. Could it be proof that Jupiter has secrets we've been missing for decades? And if so, how will it affect us humans on Earth? Well, the truth is, astronomers didn't just stumble across this phenomenon. They've been studying Jupiter very carefully for a long time. The reason is the Juno mission. The Juno spacecraft was launched in 2011, and it reached Jupiter in 2016. Since then, it's been orbiting the planet and collecting tons of data. Juno's job is to help us understand what Jupiter is made of, how its atmosphere works, and what's happening deep inside the planet. In 2020, one of Juno's cameras, called JunoCam, clever, captured something strange. Near Jupiter's North Pole, a bright green flash of light occurred. This light appeared to be moving very fast. Capturing fast-moving objects in space is extremely difficult. That's why this image surprised many scientists. So, what could this green glow be? The most plausible and widely accepted explanation is lightning. But lightning on Jupiter is very different from lightning on Earth. On Jupiter, lightning forms inside massive clouds made of ammonia and water. These storms are far stronger than anything we experience here, and they can produce unusual colors, including green. But what if the green glow isn't lightning at all? Why didn't we see it before? This glow could always exist, but it probably moved too fast for our cameras to catch until now. Anyway, if we spot it again, we would be able to study it more closely and figure out what's really going on. Until then, a lot of the explanations are still educated guesses. Another question is what this might mean for Earth. Scientists are sure it won't have any direct impact on our planet. But the discovery is still important. It shows that weather-like phenomena such as lightning exists on other planets, and sometimes in much more extreme forms. Like on Mars, for example. Scientists have just discovered that the planet's atmosphere crackles with static electricity. In other words, Mars has tiny lightning. Back in 2021, when a dust devil rolled over NASA's Perseverance rover, scientists expected to hear the usual stuff: sand scraping, wind rushing past. Instead, the rover picked up a faint pop. At first, it didn't make much sense, and now, researchers finally think they know what it was. That sound likely came from electricity discharging in Mars's thin air. Basically, mini lightning on Mars. It doesn't look like lightning on Earth. There are no bright flashes streaking across the sky. Mars's atmosphere is too thin for that. Instead, these are tiny sparks. Still, they count as lightning, which officially makes Mars the third planet beyond Earth known to have lightning, after Jupiter and Saturn. How did scientists find this? Well, Perseverance has a microphone called SuperCam mounted on its mast. Over 2 years, it recorded about 28 hours of Martian sound, and hidden in all that audio were 55 short bursts that matched what you would expect from small electrical discharges. The sparks were super tiny, like those little shocks you get when you touch a doorknob after walking across a carpet. Yeah. Each spark lasted only milliseconds, but 7 of them also lined up with electromagnetic interference. This is a big clue that electricity had jumped through the air near the rover. But where does this Martian lightning come from? On Earth, lightning forms inside storm clouds when ice particles collide. Now Mars doesn't have rainstorms like that. It's too cold and dry, but it does have a lot of dust. When strong winds whip dust grains around, they rub into each other and trade electric charges. Scientists use a long and complicated word to describe this phenomenon: triboelectrification. But the idea is simple. Friction builds up electricity. Once that charge grows strong enough, it releases. That release creates both sound and electromagnetic waves, the very signals Perseverance detected. These tiny sparks might sound harmless, but they matter a lot. Electrical activity can change Mars's chemistry. It may help create reactive chemicals like hydrogen peroxide and percolates, which break down organic matter. That could help explain why Mars struggles to preserve signs of ancient life. Electricity might also affect how dust moves. Charged dust lifts more easily, which could help dust storms grow and support themselves. That creates something like a feedback loop. More dust, more charge, more storms. And there's a practical side too. These sparks won't hurt astronauts directly, but they could interfere with electronics or damage sensitive equipment. Knowing when and where they happen will help engineers design future missions and future spacesuits to handle Mars's electrically active environment. Now, let's move further away from the Sun. Here's something that might change how you picture the solar system. New simulations suggest that Uranus and Neptune might not be giant balls of ice after all. They could actually be much rockier on the inside, with thin icy layers around. Researchers at the University of Zurich ran new models and found that these ice giants don't have to be ice-dominated to match what we observe. In fact, many of their simulations work just as well if these planets contained a lot more rock than expected. Based on the data we have today, Uranus and Neptune could be rock-heavy or ice-heavy. There's just not enough information to choose between the two. That's why scientists keep calling for missions that would orbit these planets and study them up close. Voyager 2 flew past Uranus in 1986 and Neptune in 1989. It grabbed a few measurements and kept going. No spacecraft has ever stayed long enough to really figure out what's happening beneath the clouds. So scientists rely on computer models built from limited clues. The classic ice giant picture still works, but it's no longer the only explanation that fits the data. Now, another astonishing discovery involves Uranus's moon, Ariel. Even though it's small, scientists now think it could have once hidden a massive underground ocean that made up more than half of its entire volume. That ocean could have been around 105 miles thick, and it might have existed as recently as 1 billion years ago. Ariel is only about 720 miles wide, roughly a third the size of Earth's moon. Because of that, scientists used to assume it couldn't hold on to heat for very long. Newer research doesn't quite agree. When Voyager 2 flew past Uranus in 1986, it sent back images showing that Ariel's surface didn't look old and frozen. Instead, the moon looked relatively young and active, with cracks, ridges, and even signs of ice volcanoes. Some of those features look surprisingly similar to what we see on moons, like Europa, Enceladus, and Triton. And those are places we already know have oceans beneath the ice. Later on, scientists also found traces of ammonia and carbon-based compounds on Ariel's surface. Those chemicals usually don't last long, unless something keeps bringing them up from below, which often means liquid water underground. Researchers built models of what the inside of Ariel might look like. In their simulations, the moon had a brittle outer crust, a softer layer underneath, a deep ocean below that, and a solid core at the center. After that, they tested how Ariel's crust would react to tidal forces, the constant stretching and squeezing caused by Uranus and nearby moons. It turns out that if Ariel's crust was less than about 19 miles thick, it would crack under a serious amount of tidal stress. One source of that stress could be an interaction with another moon, Miranda, about 1 to 2 billion years ago. That interaction slightly stretched Ariel's orbit and put enough strain on the crust to break it. In any case, it's too early to claim that Ariel still has a huge ocean today. It's small, and it loses heat easily. If any liquid water remains, it's probably much thinner and not exactly a great place to look for life. Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color, but so far it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. This storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy, and this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2 141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.
Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the Sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the Sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the North Pole is pointed at the Sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, Imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns, with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big swirling conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens, but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
Sand is everywhere. In your eyes and mouth, in your hair, under your t-shirt, and in your shoes. You can hardly stand. The wind is so strong, it's knocking you down. Suddenly, an especially powerful gust sends you to the ground. You crawl toward the back door. It takes you a lot of effort just to pry it open. Once inside, you get to your feet and sneak a peek outside. Just clouds of dust and a deafening roar. Okay, it's time to call for help. It started a month ago. One day, you went out to the garden behind your house. It was a windy day. You even spotted a tiny tornado under your apple tree. It hardly reached your knee, lazily swirling around tree leaves and dust. You tried to make it disappear by poking it with your foot. But even after several attempts, the mini whirlwind just didn't want to break apart. You shrugged and went back home. The next day, the tornado was still there, and had it grown? Interestingly, instead of growing taller, it got wider. At that moment, it started munching on your flowering shrubs. You got curious and decided to keep track of this unusual phenomenon. You measured it every day and carefully wrote down all the information in a special notebook. Maybe later I'll write an article or even publish a book about my storm, you thought. One day, you got out of the house to find your favorite apple tree broken. You couldn't figure out how it happened. The storm still looked harmless and too weak to damage a rather large tree. But after this accident, you started asking yourself if not calling for help was the wrong thing to do. Apparently, it was, because just a month later, your mini-storm has suddenly grown to twice its original size. It's unsafe to go outside now. It seems as if your house is in the middle of a real tornado. You can't see the sky behind a wall of dust and debris. Your garden is ruined, trees broken, bushes and shrubs pulled out of the ground and sent flying somewhere far away. You hear your doorbell ring. A group of scientists you invited has come to the rescue. You show them the garden with your personal natural disaster and enjoy their stunned silence. But after a couple of seconds of initial shock, they spring into action. Ignoring the howling wind, they start carrying inside different equipment. It looks very complicated. Your kitchen turns into the researchers' laboratory. You get informed that your house will be temporarily used by the scientists. You take your things to the smallest bedroom and watch the professionals work. Your kitchen is filled with beeping gadgets and devices covered in flickering lights. People in protective suits and lab coats scurry around. Surprisingly, they don't bump into each other. Neither do they create traffic jams. You bring the notes you've been taking and hand them to an elderly man in a white lab coat. He thanks you as if you've just given him the gift of his dreams. The next several days pass in a flurry of activity. The storm in your garden is growing. The scientists seem to get gloomier every time you see them. It's around 2 a.m. when something wakes you up. You blink your eyes open and realize the house is shaking. Your homegrown tornado must have gotten so big, it's reached the house. In the morning, several scientists pull you aside to tell you the unpleasant news. You have to move out. The storm is indeed growing. Soon, it'll wipe your house off the face of the earth. Nothing can be done. You're gaping at the people telling you to get out of your house. Where will you go? They tell you they're building an additional research lab not far from the place. It's important to be able to observe the storm in real time. Anyway, there's a spare room with everything you may need in that facility. Why don't you stay there for a while? It would also be convenient for the scientists. They may need you to answer the questions that appear during the process. You agree because you don't have any other choice. The researchers help you transport your stuff to your new accommodation. You walk around your house, saying goodbye to your favorite coffee table, your sofa, and your cozy bed. The scientists tell you that there's no time to move your furniture to another place. The next day, you wake up to the news that your home is gone. The storm gulped it down at around 4 a.m. Over the next few weeks, the grown-up whirlwind has swallowed 2 houses of your neighbors, the nearby forest, several abandoned cars, and a small flower store. It's now so big, it's coming close to a large lake several miles away from the town. People get evacuated. The authorities have announced a state of emergency. One day, you notice that scientists are talking in hushed voices. They look even more worried than usual. You corner one of them and try to find out the truth. Soon the scientist spills it. The researchers have got some evidence that confirms their worst fears. According to all their estimates, the storm that once started as a tiny tornado in your garden is going to grow into another great red spot. Only on Earth. Crimson-colored clouds are spinning counterclockwise at an incredible speed. Beneath them, you can see vibrant hues of the largest planet in the solar system, the gas giant Jupiter. Those clouds are called the Great Red Spot. It's a colossal storm raging in the atmosphere of Jupiter. If you found yourself at the storm's center, the winds would be rather calm there. But on the edges, the storm's speed can reach 425 miles per hour. That's twice the speed of the fastest and most severe hurricanes on Earth. Over the decades, the size of the red spot has been changing. Right now, it's 1.3 times as wide as our planet. The storm's roots go as deep as 200 miles into the planet's atmosphere. The average tropical cyclone on Earth usually stretches for no more than 9 miles from the bottom of the storm to its top. The unique phenomenon on Jupiter has existed for so long because the planet doesn't have a solid surface. It consists of layers of clouds made up of vapor, water ice, and ammonia. Underneath, there might be an ocean of liquid hydrogen. Our planet is solid, and hurricanes slow down and break apart once they go low enough to touch the surface. But the Great Red Spot has nowhere to make landfall. That's why it keeps raging. The scientist also tells you the most bizarre and alarming thing about the storm in your garden. Instead of growing weak and disappearing many weeks ago, it's not only still going, but it's also getting bigger and more powerful. Even the most experienced specialists can't explain this phenomenon. After analyzing it for days on end, they've come to the conclusion that it shouldn't have appeared on Earth. It's against the laws of nature. Interestingly, the storm's composition is a bit similar to that of the Great Red Spot. You're impressed, but still can't get why the researchers look so worried. It turns out that your once mini-storm is likely to grow as large as that on Jupiter. But since Earth is way smaller than the colossal red spot, it's likely to swallow our planet whole. It'll grow and grow, wiping out towns and cities, forests and highways. At the same time, it'll become more powerful. People will have to leave their homes and get evacuated to relatively safe areas, until there are no more safe areas left. This process will take years, but it'll still be too fast for people to prepare. There will be two ways to deal with this global problem. One of them is to colonize the moon or another planet, for example, Mars. But it's an incredibly long process, and the storm will conquer the entire planet before the first spacecraft with people leaves Earth. Or scientists may try to stop the hurricane. There's a technology called the sunglasses effect. Billions of tons of dense gas get pumped into the atmosphere. This gas absorbs sunlight and cools down ocean water, which is the engine of any hurricane. The researchers aren't sure if this method will work with your storm. It formed not over the ocean, but in your garden.